The master unit subrack is the interface between the RBS and the fiber distribution network. The local interface unit in this subrack converts the RF signal into an optical signal for further transmission through the fiber cable to the remote units. The local interface subrack is normally installed close to the RBS. The remote unit converts the optic signal back to RF signal and distributes it to the passive antenna. It can be either powered locally by mains or centrally by DC supply. The remote units can be conveniently installed above or below the false ceiling. Pre-connectorized fiber cables can also be used, thus avoiding the need for splicers and splice boxes in the field. A splice box usually accommodates 6 or more fiber core splicers. The splice box is installed close to the master unit and remote units. One can use spare fibers that are terminated in this box for integrating future remote units of new technologies. The fiber optical cable used for in-building distribution is of single mode. It operates at a wavelength of 1310 nanometers and has very low attenuation value, which enables the fibers to carry the signal up to 3 kilometers without sacrificing the RF output power. The most common fiber for in-building applications is the tight buffered cable with 2 or more fibers. Tight buffer cables are normally used in in-building applications since they offer small cross-section dimensions and smaller bending radius. One should handle the fiber optic cable with extra care not to affect its performance. Therefore, proper and approved tools and instruments should be used when installing the delicate fiber. The local interface is contained in a 19-inch subrack, which is mounted into a cabinet and housed in a controlled environment. In addition, this subrack accommodates the TLC plug-in units, the TFL units, and the TFL BSI that enable the leveling of the system. All cables shall be clearly labeled. Proper labeling will facilitate troubleshooting, future expansions, as well as ease of operation and maintenance. The fiber cables shall be pulled and laid inside cable conduits or on cable trays. Before one can start the splicing, the fiber is prepared according to the following steps. Outer jacket of fiber cable is removed very carefully using proper tools. The required length of cable is measured and coiled inside. The pigtails are also measured for required length from master unit to splice box. Heat shrink sleeve is inserted to one of the fiber ends. The fiber is stripped of primary and secondary coatings using the stripping tool. And the bare fiber is cleaned with ethyl alcohol and lint-free tissue paper. Make sure that clean tissues are used for cleaning the fiber. Dirty and dusty tissues can create micro cracks on the fiber core, which will introduce very high losses in the fiber and may result in broken fiber during and after splicing. The fiber core is then cleaved at the right angle by using the cleaving tool. Bare waste fiber pieces should be disposed of as per the safety standards. Poor cleaving, wedging, or curving will create air bubbles during splicing and contribute to very high signal loss. Here are some bad splicing examples. Pigtails are also prepared in the same fashion. Fiber splicing is the most important process of the whole installation. The actual splicing of the fiber is performed in 7 steps. The splice machine is set according to the type of fiber used. The prepared fiber ends are very carefully placed into the V grooves in the automatic fusion slicing machine. The covers are closed and the start button is pressed. The splicing process will progress and can be observed on the display screen. The splice loss should not exceed 0.1 dB. Once the splicing is completed, the splice joint has to be mechanically protected by inserting a heat shrink sleeve on the splice joint. The sleeve is carefully brought onto the splice joint and placed into the oven provided in the splicing machine. The sleeve is heated to the correct temperature in the oven by pressing the heat button. The splice joint is placed into its holder, and later all the spliced fibers are arranged, secured in the splice keeper, and enclosed in the splice box. Before connecting any fiber connector, one has to carefully clean the fiber tip with pure ethyl alcohol. The fiber connector has to be protected from dust and scratches and should never be left open. Unused optical connectors must always be covered with their respective caps. Fiber testing for cable lengths exceeding 50 meters can be performed by using an optical time domain reflectometer. The OTDR will indicate and determine any fiber loss, splice loss, and distance to faults. The instrument should be set for the correct type of fiber, wavelength of operation, and pulse width depending on the length of the cable. Short cable lengths that do not exceed 50 meters should be tested by using an optical test set. The total cable loss should be as minimal as possible. Maximum allowed fiber loss is 3 dB for the installed system.